Hi, my name is Manish Gupta, and in this video, I'm going to talk about ICXML. It stands for In-Context Learning Framework for Extreme Classification, for Extreme Multilabel Classification. Okay, so let's get started. So it is in fact one of the first methods which tries to use large language models, the power of large language models for extreme classification. Now, the first step to sort of realize to be able to do that is that it is not very easy to use large language models to generate labels. Remember, in the extreme classification problem, the idea is that you want to map a data point to a few labels which lie in a very large set, very large label set, right? This label set can be in millions. Okay, so typically, multi-class or multi-level classification problems can be solved using large language models by actually supplying the classes and their definitions as part of the prompt itself. But in extreme classification, the label set is too large to be put up as part of the prompt. Okay. Now, however, if one were to be able to be, if one were successful in solving the XC problem using large language models, it is also possible to solve the zero-shot extreme classification problem nicely, right? So what is zero-shot extreme classification problem? It basically means that for a large number of labels, you do not have any training points at all. So essentially, at train time, you do not see those labels or data points corresponding to those labels at all, right? But at test time, they can actually appear. New labels can appear. Okay. A very relevant problem, which is by nature zero-shot extreme classification problem, is the search problem itself. Okay. At train time, you may be given query to document relevant pairs. So here, query is the input, and documents are the labels, right? So, but at test time, new documents may come up, right? So this problem is, of course, called as the retrieval problem, where the label set can be completely different at test time. So new documents can come up, leading to zero-shot extreme classification as the problem definition. So in this problem definition, in this retrieval problem definition, the test instance is the query, and whatever we can retrieve is basically a retrieval response is the candidate label. Now, can you sort of solve the retrieval XC problem using large language models? That's the question. As I mentioned, it's not trivial to solve it because you cannot really give the information about all possible documents as part of your prompt to the large language model. Okay, so therefore, these folks propose something called as ICXML, a three-step methodology, so as to be able to solve XC using LLMs. Okay. The first step, essentially, the idea is that, of course, there has to be some sort of prompting to the LLM. So therefore, to make the prompt nicer, you basically have to come up with a short list. You cannot really give definitions of all labels, but you can give definitions of some labels, right? So therefore, something will have to manage and get a short list of those candidate labels, a very small list, so that you can say, hey, it's a candidate list. Hey, dear LLM, please basically sort of re-rank this candidate list and actually give me the right labels in the right order. Okay. Now, even to come up with this candidate list, it's actually nice if we were to able, if of course we can come up with a candidate list using some sort of basic retrieval method, which can retrieve a large set of candidates, and then we can give that candidate list to the LLM so as to essentially say that, hey, can you sort of refine these candidate lists? Okay. But rather than doing it zero shot, it's better to do it as few shot in the in-context learning setup. So therefore, this method has three stages. In the first stage, essentially, it generates demos which can be used so as to, which can be sort of thought of as the first level candidates, or also which can be used as a few short examples for your LLM prompt. Okay. In fact, this demonstration generation is also going to be done using content-based and label-centric methods, which are basically a mixture of using some sort of a retriever, a zero-shot retriever, which is off-the-shelf available, and an LLM. Okay. In the second stage, we are going to do candidate label shortlisting. We are going to say that, hey, yes, I mean, there's a label set which is basically retrieved as well as ranked by these by the initial LLM. By the initial prompt. Now I'm going to refine it further to get a good candidate shortlist. And then at the third stage, of course, I'm going to re-rank these candidates so as to get the final set of labels. Okay. So now let's look at these three steps in deep detail. So this is step number 1, demonstration generation, step number 2, candidate label shortlisting, and step number 3, label re-ranking. Okay. Now, as I mentioned on this slide, you could basically do demonstration generation using these two methods, content-based or label-centric. And of course, the third method is sort of obvious that you could just do retrieval-based. So you could just use some off-the-shelf retriever and generate a set of documents which are relevant, right? Given a test instance xi. Okay. So given a test instance xi, I'm going to call LM as phi and a zero-shot retriever as theta. So we have access to these theta and phi as off-the-shelf available techniques or tools so as to be able to do ICXML. Okay. Now, as I mentioned, there are two demonstration generation methods worth discussing. There is this content-based demonstration generation and label-centric demonstration generation. Okay. Now, the way this is done is as follows. Note that you can basically ask the retriever to give relevant labels. Okay, but the label text is not something that the LLM basically can understand directly, right? So the label text could be something which is very different. So label text could be Sachin Tendulkar, but the LLM may be able to understand it as God of Cricket. Okay. So therefore, differentiate two things. I would like to differentiate two things here. One is the label text itself, and then the other is the demo inputs, which is basically the title or some representation that you can give to that label. Okay, so that's that. And it is important that the few short in-context learning examples have both the for a data instance, they should have the labeled text as well as a representation that the LLM can relate most with. Okay, so therefore, the content-based, therefore, you're going to use a combination of zero-shot retriever theta and the LLM so as to be able to generate the initial shortlist or initial set of candidates, so to say. Okay. So I'm going to generate m into n candidates at the end of this m into n candidates. The way I do that is as follows. As soon as I get this xi, I'm going to basically ask the LLM so as to give me like m different possible outputs. Okay. Now LLM does not know the label space, so it's going to just generate the outputs. Okay. So for example, let's say if my problem is about coming up with the recommended, let's say I have an Amazon product and I want to come up with other related product titles. Okay, other related product titles. Okay. So in some ways, it's a recommendation problem. I have an Amazon product. I want other related product titles. Okay. So I can tell the LLM to do this, generate demonstration input based on test input, and specifically, please predict at least 5 relevant and diverse Amazon product titles. So that's my 5 different demo inputs that LLM has produced. Now remember, LLM could basically produce an output like iPhone 6s. Now, iPhone 6s needs to be mapped to an appropriate label, right? Because iPhone 6s may not be a label at all. I mean, it could be related to a label which may exist in my Amazon catalog, right? But it may not be exactly matching with any label. So therefore, what I need is a retriever to take these outputs which are created by the LLM, using the test xi as input and using this task description. T1 is this task description as input. Okay. I take those demo inputs that are produced by the LLM, m of them, and then ask my retriever to find n labels which are most relevant to these demo inputs. Okay. That overall gives me m into n pairs of demo inputs and labels which are relevant for xi. Demo inputs and labels which are relevant for xi. Now remember here, first I did the LLM step and then I did the retriever step. You could do the other way around, and that basically leads to the next method of demonstration generation. First, I do the retriever step, then I do the LLM step, then I do the LLM step. Okay. So how do I do the retriever step? Well, I take xi, I basically just tell the retriever, get me those labels which are most suitable for this xi. And that gives me my top n labels. I then take these top n labels li and essentially go to my LLM by coming up with a good prompt, a prompt of this kind. For each label, guess an input title. Each title is a guess based on the candidate label. Okay, that gives me my titles. Okay, my input titles or demo inputs, as I may want to call them. Okay, so overall, whichever method you do, whether you do label-centric demonstration generation or content-based demonstration generation, what you end up with is this. A list of m into n, overall m into n, input titles and labels, input titles and labels. Okay. Now you take all of these and go to the next step called as candidate label shortlisting step. Okay. So the idea here is that you would do few shot in context learning based inference. So what you're going to do is to take these demo sets that you've generated and integrate them with each test instance xi. So you take xi and you combine them with your di. Remember, this is not very large. So in the paper, they basically use m into n is equal to 25, m equal to 5, n equal to 5 in that sense. If I remember correctly, maybe they use n slightly larger. But the idea is that these total number of examples is very small. They can actually fit in a prompt. Okay. So you integrate these demo sets with the xi, like that, and then add a new, text description for the prompt. Please predict at least 10 relevant products for a new Amazon product title. OK, so you essentially give it these examples and you ask it to predict relevant. You don't tell it that, hey, you have to predict from these only. You basically tell it that, hey, here are the pairs of product titles and labels, product titles and labels. Based on that, please come up with at least 10 relevant products. OK, that's that. Now, remember, this may seem very similar to this guy, but that's not the case. Here, you're actually supplying so many demo examples, while here you did not have any demo examples at all. Okay. So that's that. Now the LLM comes up with YIJs, some 10 relevant product titles. You basically have to use again your retrievers just to map these 10 different things to the labels in the label space. Okay, so therefore you need to do label space mapping. Okay. Now that basically gives you at least 10 relevant labels which are denoted here, 10 relevant labels for every xi, for every input xi, 10 relevant labels. And therefore, the last step that you do is label re-ranking. You basically just tell the LLM that, hey, here's the shortlist. The LLM is y, right? So here's a shortlist yi bar. And my task description is as follows: given a query product, select the top 10 most relevant products from the list of candidates. I'm giving you a list yi bar. Don't go beyond that list, OK? And select the top 10 from that only. And that gives you overall 10 labels that you can directly show to the user as retrieved by the XE setup. So this is basically overall XE plus LLM setup in that sense. Okay. In this paper, the particular LLM that they experiment with is GPT 3.5. They also do some experiments later with GPT 4, but main results are with GPT 3.5. For the retriever, you could use several retrievers which are available. In their case, they use one of the state-of-the-art retrievers, TASB. They also, specifically for the ICXML setup, they basically do not train this retriever. They just use the zero-shot retriever. But you could use the trained retriever as well. You could basically train your retriever as well, right? So that's that. So they compare with several other retrieval methods, and they also compare with the free generation method using a single LLM, which is basically just a one-shot thing. Basically just says, here is my Amazon product, and please generate 10 titles for it. OK. So they experiment with the two different data sets, the WikiC also titles and Amazon data set. So, and on both the data sets, you observe that ICXML methods perform better compared to any of the previous retrieval methods like TF-IDF, PM25, TASB, and so on, even if those methods were actually fine-tuned on the labeled on the training data. Okay. Amongst these ICXML methods, what you observe is that label-centric approach performs better than the content-centric approach. Typically, your label-centric approach essentially gives you way better results compared to the content-centric approach. So what does that mean? That basically means that it is better to actually use the retriever first, get some retrieve labels, and then get the LLM, use the LLM to actually obtain the input titles, pass them through another LLM call so as to get a candidate shortlist, and then do re-ranking. Okay, so that's that. OK, so in summary, in this video, I talked about how you can leverage large language models for extreme classification. And if you can do that, you can actually now start supporting zero-shot labels. OK, so doing it trivially just by making an LLM call is not possible because the label set in extreme classification is very large. You can't give the set of all labels, right, as part of the input. Okay. Doing it free form is also not a great idea. Free form means, just ask LLM to come up with relevant labels. Well, it may come up with some labels, but they may not map to your label space at all. Okay, so therefore, these guys came up with a 3-step methodology so as to be able to use LLMs for extreme classification problems. In the first step, they do demonstration generation, trying to bridge the gap between the text used to describe the labels and the text that an LLM would generate to be able to come up with labels for a given test instance. In the second step, they do label shortlisting, and then in the third step, essentially they do label re-ranking so as to be able to find the final list of relevant labels for a test data point. Okay, so that's it for this video. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my search on my homepage. Thank you.